In this section, we'll be talking about functions. Now, functions, we're just going to get an intro here because they're not used that much in algebra, but once you get into calculus and higher mathematics, functions are actually used quite extensively. So I just want to get you familiar with about what they look like and what their uses are. So a function, you can think of it as sort of a machine. You have an input, you put something into this machine, and what the function does, it's going to scramble up and do all sorts of magic onto this input, and it's going to spit out an output. Okay, so you put in a number, an expression into this machine, and it spits out something. And this machine comes in the form of, at least in this course, it's going to be called f of x. This is our function. F is not a variable. F just stands for function, and our variable is x. This is the input. Whatever we substitute in for x, the function is going to take it and it's going to spit us an output. Okay, so let's say we have the function f of x, and we're going to have an equal sign just like we do in equations, and then we're going to have an expression on the other side. So let's say we have the function f of x equals the expression 5x minus 2. Okay, so whatever we substitute for x as our input in the function, we're going to substitute in for x in our expression. So if we had f of 1, we want to substitute in 1 for x. So we're going to put a 1 everywhere we see x in the expression over here, and then we solve. So we input a 1, and the function's going to scramble it up over here and output something. Okay, so if we have 1 right here, we had 5 times 1, which is 5, minus 2, which is 3. So f of 1 would be 3. So a function's sort of a machine, and while we're not going to do it in this video, we're going to concentrate on what are all the possible inputs that we can put in this function, and that'll give us a set of numbers that are actually valid. So all the possible inputs that we can put into f of x is called the domain. The domain. Those are all the possible inputs that we can substitute in for x. And this one's pretty general, and in this example, a domain is actually the set of all real numbers. All real numbers. So we can put any number here, fractions, decimals, whole numbers, negative numbers, anything can go in here, and whatever the output is called the range. Okay, so after the function takes in the input and spits something out, that is called the range. This expression isn't called the range, but after we put in a number and it spits something out, that's the range. And the range is all the possible numbers that the function can spit out. And in this case, it's actually the same as the domain. It's all real numbers. Okay, so we can put any number in for x, and it'll spit out any possible number. It just depends on what number we actually use for our input. So this is actually the most common case is that we have a, computer's freaking out. This is actually the most common case when we talk about domain and range as far as function goes. We're able to put in all real numbers, and the range will spit out all real numbers, but that's not always the case. Let's take a look at this function. We have f of x equals 3x squared minus 1. We want to know what the domain and the range is. Okay, so what's the domain? The domain is all the set of numbers, or the set of all numbers that we can actually substitute in for x, that we can put into this function. And there's actually, that will be the set of all real numbers. This function can take on any real number, is all that means. That's the domain. Now let's talk about the range. Okay, now the range is actually dependent on whatever number we put in here, especially in this example, because the smallest number that the function can put out as far as this expression goes is minus 1. We can't put out a smaller number than that. And if you think about that, it makes sense, because this x term is squared. So if we put in f of 0, we would plug in a 0 here. And this would be 0, and our function would spit out a minus 1. And if we put in any positive number here, we would have at least 3. If we put in a 1 right here, we'd have 3 minus 1, which is positive 2, and so on and so forth. If we put in negative numbers, we're going to square any number that we put in here, so we're actually going to get a positive number every time. So this entire expression can never be less than minus 1, no matter what real number that we put in here. So the range, or the possible set of numbers that the function can spit out, is the set of all real numbers greater than or equal to negative 1. And that's the range. That's the set of all possible numbers that this function can spit out. So it can input any real number, but it can only spit out any real number as long as it's greater than or equal to minus 1. It can never spit out something smaller than minus 1. And that makes sense because this x term is squared here, so we're always going to have a positive term right here on the left side of the expression. All right, let's look at another one. Let's say we have the function f of x equals 4 divided by x. Okay, now this is the one we usually have to watch out for. One of the few cases. Let's go ahead and identify the domain and the range. Okay, so the range, or the domain, is the set of all numbers that we can input for x. So whatever we put in for x, we're going to substitute into our expression on the right-hand side. And there's actually only one number that we can't substitute in for x. That would be 0. We can't have division by 0. We learned that when we were talking about linear equations. It leads to an undefined, so we can't plug in a 0. So the domain is the set of all real numbers except 0. Okay, we can plug in anything that we want into here, any number except for 0. Now the range is what this function is going to take in and spit out. So it's going to take in the domain and it's going to give us the range. And as long as we don't put in a 0 here, we'll actually get any real number. So the range is going to be the same as the domain. It's going to be all real numbers except 0, just depending on which number we choose. But we can't choose 0. Okay. Pretty straightforward. These are actually the basics of functions. Let's look at a couple more. Let's say we have the function f of x equals x squared minus 2. And we want to choose a couple specific numbers to put in for the domain. So we want to know when f of x equals x squared minus 2, when the domain, or the set of all numbers that we can put in for x, we want to size it down into these few numbers: minus 1, 0, 1, and 2. So we want to know what the range is when we limit our domain to just these 4 numbers. What we would do is, one at a time, pick one of these numbers and put it into our function, and which would essentially, we would substitute it in for x and see what that answer will give us. So if we substitute in f of minus 1, we will put a minus 1 right here. So minus 1 squared minus 2 is what we will get. This is what's called f of minus 1. All right, so we just evaluate our function with x equals minus 1. And this would essentially give us 1 minus 2, which is minus 1. So that's one number in our range. Let's do f of 0. Plug in 0 everywhere we see x. 0 squared is 0, so we'd have a minus 2. Let's do the same thing for 1. Plug in 1 for everywhere you see for x, so we'd have 1 squared, which is 1, minus 2, which is just minus 1. And this minus 1 and 1, when we plug in, when we evaluate the functions at those two values, we actually get the same answer. We get minus 1. And this makes sense because regardless of the sign, we should get the same number when we're squaring the number. Okay, so minus 1 squared is 1, and 1 squared is 1. So that actually makes sense. All right, now let's try 2. We put 2 into our function. We get 2 squared, which is 4, minus 2, That gives us 2. So the range are these 4 numbers when the domain is limited to these 4 numbers. Okay, so all we're doing is simply limiting the domain, and we're plugging it in for our x. So if we have f of minus 1, we plug in minus 1 everywhere we see for x. We're just substituting in a number for our variable. Let's go ahead and look at another one real quick. Let's say we have f of x equals x plus 1/2, and we want to know what the range is when the domain is limited to the following numbers. Let's say the domain is -2, -1, and 3. We want to know what the range is. So the range is going to be, well, our function evaluated these 3 values. So f of -2, we plug in -2 for x. -2 plus 1/2 is going to give us a -3/2. Plug in -1 for f of -1. -1 plus 1/2 will give us a -1/2. And for 3, well, we just evaluate f of 3, or we evaluate the function at x equals 3. So we plug in 3 for our x. 3 plus 1/2 will give us 7/2. So this is our range when the domain is limited to these 3 numbers. Okay, so we're talking about domain and range here of functions. The domain is the set of all numbers that we can substitute in for x, that we can evaluate our function for. And the range is whenever we put a number in there, and the function, if you think about it as a machine, we put something in and it spits out an output. Well, the output is called the range. Okay, so the function takes in the domain and gives us a range. And the domain is all the possible numbers that we can put into the machine. That's called a function. The range is all the possible outputs. Okay, so I want to get familiar with this, familiar with the terminology, because we'll deal with it again in this section. We'll talk about functions and talk about their uses and how we use them in the real-world applications, and definitely want to get you ready in case you're going up to calculus and higher mathematics. You'll see functions quite extensively. So we'll go over much more of this in the future videos. I'll see you soon.